So we left off here with three-part inequalities, also called double inequalities. I should have put that up here somewhere, aka double inequalities. Double because they have two inequality symbols. Inequality. Okay? Because there's two of the less than symbols or two of the less than or equal to symbols, that kind of thing. So that means that they're sometimes called double inequalities. All right, so let's solve some double inequalities by hand, yes. And then we're going to have to write the answers in interval notation and graph. Okay, well, in theory, they look more complicated, but in general, they're not. So let me type this one. -1, whoopsie, less than 3x minus 7 is less than 5. Okay, so what you want to do is you want to solve it for x, right? You want plain x alone in the middle, just like you did up here, right? So up here I have x in the center by itself. So I need to get x by itself. And you're going to do this, I mean, pretend that the less than 5 wasn't there, right? What would you do? You'd add 7, right? To make the minus 7 go away. And so the deal is you add 7, but you just add it to the left, you add it to the right, and you add it to the center. All three of them get plus 7. See? You're really doing two things at once. You're doing this inequality and, whoopsie, this inequality at the same time. You didn't know you could multitask like that, but I did. All right, so you're going to add 7 to the left, add 7 to the center, add 7 to the right. You add 7 to all of them, okay? Because it's in this kind of weird non-equilibrium, and you've got to keep it that way. All right, -1 plus 7 makes 6, less than 3x, which is less than 5 plus 7 makes 12. All right, now you want to divide by 3, right? Because you want to get rid of the 3. Well, that's fine. You can divide by 3 all you want. You just have to do it to all of them. You got to do it over to the left, you got to do it in the center, and you got to do it on the right. All right, so that gives you 2 over here, because 3 goes into 6 2 times, is less than 1x, which we would just write x because we're lazy. Exactly. Math people are lazy. Why write 1x when you don't have to? And then 4 over here. So there's your answer right there. 2 is less than x, which is less than 4. That's inequality notation. Let me just make a note. That's the inequality. Okay? Inequality notation, I should say. Notation. All right, now, what about graphing it and interval? Now, I know they said interval first, but again, I would totally recommend graphing first. Let me go get a graph. There it is. So I want 2 to 4, but 2 and 4 themselves have to be open circles because you don't actually get to them, right? You just get up to them. So you graph from 2 to 4, open dots on both. And that's kind of a clue about your interval notation because since you've got open dots on both, that means they're both going to be parentheses. So that's your interval notation. I know it seems weird, but this parentheses thing and that inequality up there that I've boxed are both the correct answer. And the trick is that in Math 141 and beyond, the bottom one is the one that we'll actually be taking. In earlier classes, it was the top one that we would take. And in later classes, the bottom one. It's sort of like f of x notation. It's like, you know, oh, why do we use that? It's when y will work. It's like, well, y doesn't work for more advanced problems. And for more advanced problems, believe it or not, this is actually the better way to write things instead of the less than symbols all over the place. Okay, now let's do it again, but with fractions. That's got to make it harder, right? Okay, so we've got 1/2 is less than, I think. Let me flip it. Less than 3 minus 5/4 x, which is less than or equal to 7/2. All right, now again, we don't like all this fraction business. I think I got it right. Yep, I got it right. So what we're going to do is we're going to multiply everything. Whoops, we're going to not make it so big. We're going to multiply everything by the LCD. Now, you have a choice, right? You could, to be honest with you, it doesn't have to be the least common denominator. I mean, you could pick all sorts of numbers that would work, but it has to be a number that 2 and 4 all go into, all divide into, if you will. So the lowest of those numbers would be 4. 4 divides into 4, and 2 divides into 4. That would be the best, right? And that's what we're going to use. So I'm going to take that, and I'm going to multiply everything by 4/1. Oops. So 4 over 1 times that first one, right? 4 over 1 times the 3, yeah, times that. 4 over 1 times the 5/4, and 4 over 1 times 7/2. All of them, every single term gets 4 over 1. First one, second one's the 3, the third one's that 5/4, last one's the 7/2. Everything that's separated by a sign or an addition or subtraction symbol or an inequality sign, all of them. Now, I know what you're thinking. You're thinking a lot of that did not make things easier. Oh, but it did. Look, 2 goes into 4. See that part right there? 2 goes into 4 how many times? Twice, right? So you say, okay, 2 goes into 4, leaves you a 2. So that number is 2. All right, now we got the less than symbols, right? Less than, right? Because we took care of this. This whole thing turned into 2. Now here we've got 4 over 1 times 3, but nothing cancels there because this is really 3 over 1. So it's just 4 times 3, which is 12. Minus, that's this minus right here. That's that minus, right? Because this whole thing became 12. Now here you've got 4 divided by 4, which last time I looked makes 1, right? And 1 times 5 will just give you 5. So it's 5x. Now I need a less than or equal to. Over here, 2 goes into 4 twice, right? Because if 4 divided by 2 makes 2, so you've got 2 times 7, which makes 14. One step, it's really ugly, but all your fractions are gone, right? And if they don't all disappear, then you did not pick the right number or you didn't multiply correctly, I should say. The one thing that I will say is that a lot of students don't do the 3. They know to do 4 over 1 times this, they know to do 4 over 1 times the right, and then they'll do 4 over 1 just times the x part, but they'll forget to do the 3. But you got to do the 3 because it's really the whole center. Let me put it this way. This whole thing has to get multiplied by 4. So you have to distribute. That's what you're doing. You're distributing 4 times the half, 4 times the 3, 4 times the 5/4, 4 times the 7/2. Every one of them gets multiplied by 4. And I just like to think of it as 4 over 1 to remind myself that it's in the numerator. All right, once we're at this point, this is not a hard problem to do. We want to get the x part by itself. So we're going to subtract 12. We do it to the left, we do it to the center, and we do it to the right. That's going to give me negative 10 less than negative 5x, which is less than or equal to 2. Then I want to divide by negative 5 because I want to get x by itself. I'm going to put negative 5. Negative 5, negative 5 over here. And that's going to give you your answers. But be careful. So make a note. Write note. Divide by negative 5. So we need to flip the sign, right? Pay attention. Anytime you ever divide by a negative, you must flip your sign. So that means, so negative 10 over negative 5 makes positive 2. Greater than, see, you got to flip your sign. Not less than, right here, see? Was a less than, became a greater than. This is going to be x. And then less than or equal to, oh, excuse me, greater than or equal to, I'm losing my mind, negative 2/5. There's your inequality. It's kind of badly written. We generally like the lower end first. So let me change it. Negative 2/5 is less than or equal to x, which is less than 2. Right? So these are both correct. Either way you want to write it. X is between 2 and negative 2/5. You could say, look, 2 is greater than x, which is greater than or equal to negative 2/5. Or this is the low end, right? Because that's the lowest number. So I could say negative 2/5 is less than x, less than or equal to x, which is less than 2. See the pointy end, look, pointy end on the x, bigger end on the 2. Pointy end on the x, bigger end on the 2. Up here, pointy end's on the negative 2/5, and the mouth is eating the x. I got the same thing right here. Pointy end is on the negative 2/5, bigger end is on the x. If you did not flip the sign, then what would happen is you'd say 2 is less than x, which is less than negative 2/5, which, think about what that means. Ultimately, you're telling me that 2 is smaller than something which is smaller than negative 2/5. So you're saying 2 is less than negative 2/5, which makes no sense at all. So if you did not flip the sign, if you left it less than and less than, that's what you would have gotten, which is totally wrong, right? So you've got to flip the sign whenever you divide by a negative because of what you just saw, right? If you don't, then it causes it to be wrong. So I'm going to put this in a box as well, because technically this one is also correct. They're both correct. So if they care about whether or not the smaller end is on the left, then fine, use this one right here, because this one has the smaller number on the left. If they don't care, then the other one is fine as well. For me, on written tests, I don't care. Either one of these is perfectly correct. All right, now we still need a graph and an interval. So let me see. Let me grab a graph. Hold on one sec. There we go. So there's the negative 2/5, which is about 0.4. So you could say negative 0.4 is less than or equal to, that's why it's got a dot on it, because, or the closed dot, excuse me. And then over here at the 2, we have an open dot, because you don't actually get to be 2. Okay, what's that going to mean for our interval? Well, let's look at it some more. You've got a closed dot on the left, you've got an open dot on the right. So it's going to mean a bracket on the left, a parentheses on the right. So you could take negative 2/5, comma 2. Left-hand edge is negative 2/5, and you get a bracket because you got a closed dot because of the or equal to part. And then the 2 gets a parentheses because it's an open dot, because it was just a plain less than or greater than, depending on which way you want to look at it. And that's interval notation. So we have the inequality notation boxed up above. Ooh, I should box this. And then we have the interval notation right here. Put it right there. Done. All right, let's do the last problem quickly. We have in section 3.3, we modeled beer and hard liquor. Remember, we found those equations. H of T was hard liquor. It was, excuse me, the share of alcohol consumption that was hard liquor. It's 0.375 T plus 29. Beer is negative 0.5 T plus 58. So that is the share of alcohol consumption for hard liquor and beer respectively. So on the graph, I've got each one. Now, question is which one's which? Aha. All right, so think about it. H of T, the hard liquor, is increasing because it has a positive slope, right? So which one of these two has a positive slope, the solid line or the dashed line? Hopefully you said the solid line, right? Because it's got a positive slope. Starts at about 29 and is going up. The beer, on the other hand, is decreasing, going down. So that has to be the dashed line, B of T. All right. Now, for what values of T is H of T greater than B of T? Hold on one sec. Okay. So looking at the graph, when is hard liquor higher than beer? Okay, if beer is this dashed line, beer is above, right? More alcohol sales were beer back in whatever year that was, right? So back in that year, it was more beer, more beer, more beer, but it's decreasing. At this point, they're equal, and then from then on, beer is less. So hard liquor is greater than from this point on. And we found the intersection point. Let me go back and find that. There it was, back on page 54. We found that it was 33.14. So I'm going to use that down on the last page. Hold on, let me pause you. There. We found that they were equal at 33.14. Therefore, it appears that H of T and will be bigger than B of T from that point on. So when T is greater than 33.14, i.e. 33.14, comma, infinity. Now we have to do it by hand as well, but we're out of time. I'll have to do that in the last video. See you then.